Hi, I'm Marissa, and this is my speech, Nature's Nightlights. Imagine you're in the dark depths of the sea, the water is ice cold, and you can't see a foot in front of you, but out of the corner of your eye, you see a faint light in the distance. Upon a closer look, it's a glow in the dark octopus. But it's not so much of a light up toy than it is a real animal living and breathing that can glow. Their ability to do this is called bioluminescence. In these next few minutes, I'm going to explain how these animals light up, why they do, and the types of it that occur in nature. Bioluminescence is a very unique natural phenomenon that I think is often overlooked. So I think it's important to learn about and cool to know about. So, what exactly is bioluminescence and what is the chemistry behind it? After that, I'll dive a little deeper into the different types of it, and finally, I'll explain some advantages of the ability for animals in the wild. So, first, what exactly is bioluminescence and what is the chemical reaction behind it? According to Tim Kalki of Current Biology, bioluminescence is the emission of light by an organism as a result of a biochemical reaction. It's a little complicated. A light-emitting molecule called luciferin acts as the fuel of the reaction, and luciferase is an enzyme that acts as the spark, catalyzing this reaction. For light emissions to happen, luciferin must react with oxygen in the presence of luciferase, moving the luciferin to a more energetic chemical state. Then it lowers, releasing excess energy in the form of light photons. The luciferase can then be recycled, and the reaction continues to occur over and over again, keeping the organism glowing. Now, what are the different types? There are two main types of bioluminescence. The first is internal bioluminescence, like a firefly. This is when the luciferin light reaction happens within the organism's body. The second type is symbiotic bioluminescence, where bacteria or small bioluminescent organisms attach to larger organisms, making the creature appear as if it is glowing. For example, Hawaiian bobtail squids host bioluminescent bacteria that produce the light for them. Chemical variation is also something to consider in bioluminescence. While the basic light reaction is the same among all organisms that experience it, different species use distinct luciferin and luciferase molecules, which lead to a wide variety of light colors and characteristics. So, how does this translate to real life? The use of bioluminescence is the primary reason these organisms survive. Stephen Haddock of Annual Reviews explains that bioluminescence is clearly a predominant form of communication in the sea, with important effects on the immense daily vertical migration, predator-prey interactions, and the flow of material through the food web. So what does that mean? Many sea creatures can use their ability to glow for communication and attracting mates. They may also use it for defense so they can startle or distract predators to stay safe, or camouflage by blending in with the slight glow from the water surface to avoid these predators. The glow can also be used to attract prey. Smaller organisms will follow their light into dark areas where the predator will then attack. Anglerfish use this method in the deep sea to get their prey. They have a glowing lure that hangs off of their heads that they use to attract smaller, curious organisms who then swim within striking distance of the fish. This ability is essential for the survival of these organisms. So now you know the science behind bioluminescence, the two main types of it, and how it's used in their everyday lives. Bioluminescence is an amazing phenomenon that is rare but incredibly useful. Bioluminescence is more than beauty, it's a window into how a creature adapts to their surroundings. Whether it's used to find food, avoid danger, or simply communicate, these glowing organisms remind us that even in the darkest depths and in the darkness of night, nature finds a way to shine. Thank you.